Hey everybody, ArtDude47 here, and today I'm here with a new kind of video. I actually originally started my channel to showcase programming projects I'm working on, and I used to do that in Blitz Basic, and basically I've grown on from Blitz Basic and I've still been programming and still making games. And so today I wanted to try making a little tutorial. What I wanted to do was try to make a third-person character controller tutorial and show you my workflow and show you how I would do it in the newer versions of Unity using the new input system. And so with that said, let's get started. The first thing I'm going to do is create a ground. So I'm going to create a 3D object and I'm going to make a plane. And then I'm just going to get us focused so that way it would help if I was in scene view rather than game view. So we're going to just make the plane pretty big. I'm going to make it 20 by 20. And we're going to call this ground. Then the next thing I want to do is create a 3D object. I'm going to make a capsule. And let's focus on the capsule. We want to bring it up onto ground level, so we'll make that 1. And I'm going to call the capsule body. And this is going to be our player's body, which is why I'm calling it that. We're going to go ahead and remove the capsule collider. We're actually not going to need that for this, so get that removed. And then as a child of the body, I want to create another 3D object. I'm going to use a cube. And I want to call this one head. Now I'm going to scale it down to 0.5 on all axes. And then what I'm going to do is move it up and forward to make it on the face section of our model. And basically what this is going to do is let us see which direction the character is facing. I also want to remove the box collider from here. So we're going to remove that. And then the last thing I'm going to do for the player is I'm going to create an empty game object. I'm going to set it to 0, 0, 0. And I'm going to name it player. Also going to make sure the body is at 0 and 0. It's on 1 because we want it on the ground. And then we're going to make that a child of the player empty. And the reason I do that is just to keep things clean. That way the mesh renderers and things aren't taking up space where I'm going to have my scripts. And so then once that's done, we've got our player set up. The next thing we're going to need to do is make a camera that follows him, and we're going to need to get the new input system. So from here we'll click Window, Package Manager, and we'll get the packages that we need for that. Before you do that, what you're going to want to do is file and save, because the input system is going to require us to reset Unity. So from here, just type input in the search field, and you want to make sure you're in the Unity registry, and it's the input system. Click install, and we'll wait for that to install. Alright, so once that's installed, you're going to get this pop-up saying that you need to restart the editor to enable the new input system. So we'll click yes. Once we're back into Unity, that's taken care of. The other package we're going to need is called Cinemachine for the camera. And so let's go ahead and install that. Right, and so with that installed, the first thing I'm going to do is bring the game view side by side with the scene view. And so the first thing you can see here on the game view is we do have a view of our player, but the camera doesn't follow the player. And so just to really drive home what I'm saying, we're going to go back to our player game object. We're going to add a component, and what we're looking for is a character controller. Now with this character controller, we're going to have to change the position on the Y to 1. Yeah, so we need the position on the Y of the base player object to be 1, and then we'll make the body 0. And that'll just make sure that it's lined up with the base player object. And now you can see we've got this green capsule around our player capsule. What that is the character controller. It's going to handle the movement as well as the collisions for us in this project. And so what we'll do from here is we'll add a little movement. And the way we'll do that is by going to our assets folder. We'll go to create and a new folder, and we'll call this one scripts. And in the scripts folder, we'll create a new C# script called player controller. And before we open that, we'll need one more thing on our player component. So go back to your player, go to add components, and what we'll want is a player input. So click on player input, and then we'll need to create actions. So I'm going to create a new folder. I'm going to call it inputs, and then I'm going to call this player input. So we'll choose our player input in the actions field, and then if we pull that up, what player input does is it creates a lot of the default inputs that you would expect on a player controller. So we already have move set up. It'll take left stick, WASD, and we have a look set up, which does right stick and the mouse pointer position. Now with all of that set up, we're ready to open our script. When the script is open, we can go ahead and get rid of the start, and we're going to need a few variables. So the first one we're going to need is a reference to our character controller. So we'll call it a public character controller, and then we're going to need a variable to control the speed of our player. So we'll call that a public float speed, and we're going to go ahead and give that a default value. I'm just going to choose something like 5F. And we'll be able to play around with that and see how we like that. And then the last thing we'll need right now is a private vector3, and we're going to call this movedir, short for move direction. And the reason this one's private is because we're not going to set it in the inspector, we're only going to set it through code. So we don't need it to be public. Now that we've got the player input attached to our character, we can actually access our movement fairly easily. So what we're going to want to do is make a void method called onMove, and you're going to want to accept some arguments on this method. What we're going to need is input value, and we'll call it value. Now we're going to get the red line here because what we need to do is we need to be using the input system. So we'll add using Unity Engine .input system, and that will give us the onMove function. And basically this input value says it's going to pass us the value from this player input we set up. So move, it will pass us the value, like if W is being pressed, A, S, or D. Now the first thing we want to do is convert this value into something we can use. In this case, we'll make it a vector2. So I'm going to do var input vector equals value.get vector2. And so what that does is it gives us just a temporary variable we'll use called input vector, and it's going to turn this value into a vector2, so that way we can get how we're moving on X and Y. Then from there what we'll do is we'll make movedir equal new vector3, and we want the X value to be input vector dot X. We want the Y value to be 0 because we're not jumping, we're only moving up, down, left, and right. And then we want the Z value to be input vector dot Y. It has to be dot Y because this is only a vector2, so it doesn't have a Z value. Alright, so essentially what we're doing is we're getting what movement buttons the player's pressing, and we're converting those into a vector 2, and then we're adding that to our move direction vector 3. Now in the update method, what we want to do is check if our move direction is not equal to 0, if it's greater than 0. So we'll do if movedir.magnitude is greater than 0.01, then we're moving. And so what we want to do is put controller.move, and we will move by the movedir, and we'll multiply that by our speed, and then we'll multiply that by time.delta time. And all that's going to do is make it frame rate independent, so that way if you have a super fast machine with very high frames per second and a mid-level machine with pretty low frames per second, they're going to move at the same rate. So let's save this script, and let's go back into Unity. And now on our empty player game object, we're going to add the player controller script. And for the controller, we want to drag our character controller there. And if we hit play, we can now move the character forward and backwards and left and right, and any combination in between. There's just a few problems. The first one is that the camera doesn't follow our player currently, and the second is that our player doesn't rotate the way he's moving. So first, let's handle the camera using Cinemachine. If you've noticed, there's a new link up top in this bar for Cinemachine, and we'll click on that and create a free look camera. You want to make sure you're back in your scene view, and under the Cinemachine free look camera, there's a follow and a look at. We want to make both of those our player, so I'm going to drag him into the follow and look at. Now what you'll see is there's 3 rings around our player. If I bring the game back here, you can see we're now looking at the player, but we're very close to him. The camera defaults onto this middle ring, and then it can move to the lower ring and the upper ring to look at him. So if we go into our free look camera and we take a look here at the orbits fields, what I want to do is increase the radius a lot. So the first top ring radius I'm going to make 12. I'm going to make the middle ring 15, and I'm going to make the bottom 12. And so already you can see now we've got a better view of our character because we're farther away. Now there's a few other things we need. The first one is a new component. Because we're using the new input system, we just have to give our Cinemachine an override to use the new input system. So if we click Cinemachine Input Provider, and then on the X and Y axis, what we'll do is player look. If you go back to your player inputs and take a look at the look, you'll see it's already set up to use the right stick of a gamepad or the delta position of the pointer, which is basically just your mouse position. And so if we go back and play our game, you'll see that now you can rotate the camera around the player using your mouse. And the camera follows your player when you're moving. So now we really just need to tackle the problem that our player doesn't face the direction he's moving. But before we do that, I want to do a few things just to make our scene a little more viewable. So I'm going to make a new folder. I'm going to call it Materials. And I'm going to make a new material called Grass. And I'm just going to adjust the color for our grass material and make it a green. And I'm going to apply that to the ground in the scene view. And then I'm going to make a player material as well. And just to make him easily viewable, I'm going to make him like a light blue color. we'll apply that to the player's body and to the player's head. Alright, so with that done, we're ready to work on rotation. Alright, so to work on the rotation of our player, we're going to want to go back into our scripts, and we're going to want to create some new variables. So here under if movedir.magnitude is greater than 0.01, we're going to make a new variable. It'll be a float, target angle, and what we're going to set this to is mathf.attan2, and we're going to make this the movedir.x and the movedir.z, and then we're going to multiply that by mathf.rad2degrees. So what we're doing is multiplying that by mathf, and this is radians 2 degrees. And so I know this looks confusing, so I've got here pulled up the Unity documentation, and basically this returns the angle in radians whose tangent is y divided by x. So it returns the value is an angle between the x-axis and a 2D vector starting at 0 and terminating at xy. And if you look at their code example, they give you a little more information on how this works. So back in our code, basically what we're doing is we're getting the angle that the player should be facing based on the movement. And so next, what we want to do is actually apply that. So I'm going to make a new float. I'm going to call this one angle, and we're going to make this mathf.smooth damp angle, and it's going to be transform .Euler angles .y target angle. And so you can see we've got the current angle, we've got the target angle, the current velocity, and the smooth time. So we called our target angle already, target angle. And so then the next thing we need is the current velocity, which is a float. So what we'll want to do is actually make a variable to hold that. We'll call it private float rotate velocity, and then there's a smoothing speed, so we will make that one public, and that'll be public float rotate speed. And to start with, we'll make that 3f. And so now if we apply, we'll put the rotate velocity and we'll put the rotate speed. Oh, and we need to put ref here for this to work. So that has to have the ref keyword. So basically what this is saying is mathf.smooth damp angle. Let me just pull up the Unity documentation for this one too. What this does is gradually changes an angle given in the degrees towards the desired goal angle over time. So this is going to make it smooth and not just an instant snapping motion. And so what we're doing is we're taking our current angle at the Y position, because that's what we want to rotate to face something, and then our target angle. And then we've just got this velocity. This is basically just something Unity uses to make sure that it's properly going over the time based on the rotate speed. And so the last thing we want to do here is make our transform.rotation equal to a quaternion.Euler, and we're going to make it 0f on the x, we're going to make it angle on the y, and 0f on the z. And for the last piece of Unity documentation, I already pulled up the quaternion.Euler, And basically this returns a rotation that rotates z degrees around the z-axis, x degrees around the x-axis, and y degrees around the y, applied in that order. And so if you look at their code example, it's a 30-degree rotation around the y-axis. And so that's exactly what we're doing here, except we're going by angle degrees based on how many degrees it needs to rotate based on the character movement. So if we go back into Unity and click play, you'll see now that if I move right, the player slowly moves with it. What we need to do is change the speed because that is not working very well. So let's play and let's change it in real time. I'm going to slide it way down to maybe 0.3, and I'm going to try to move the player again. And that's still a little slower than I would like. So I'm going to make it 0.1, and now I think that's a pretty good value for how fast our player should move. So we're going to stop playing, we're going to change it back to 0.1, and now we've got that rotation set up for our player. Now there's a few other things that we need to address. The biggest one being that if you go to play mode and you rotate your camera and then you walk forward, the player's movement is not in any way affected by the camera movement. And for most third-person games, you do want the camera movement to affect your player. So let's tackle that next by going back to our script. Alright, so in our code here, we're going to need a few things to make the camera rotation. First, we need to get the transform of our camera. So I'm going to put public transform camera . And there's already a Unity component called camera, so I'm just going to change it to cam so that way we don't get any problems. And so from here, we've got the transform for our cam. There's just a few things we need to change. So when we're getting our target angle here in the update function, after we multiply by mathf.radians to degrees, we just want to add the cam dot Euler angle dot y. So we'll add in the y rotation of our camera. And then the next thing we want to do is we want to make a new vector 3. So what I'm going to do here is make a vector 3, and I'm going to call this movedir cam. And so this is going to be our new movedir taking the camera into consideration. And we're going to make this equal quaternion dot Euler. It's going to be 0f target angle (0f), and then we're going to multiply by vector 3 dot forward. Alright, and so now that we've got that taken care of, what we want to do is change our code to move, and rather than using movedir, we're going to use movedir camera dot normalized, or movedir cam dot normalized, and then we're going to still multiply it by speed and then time dot delta time. And what we should get now is player movement that also follows the rotation of the camera. Of course, you must remember to assign the camera. So under this script, we're going to take the main camera, not the free look camera, and assign it there. One other thing I'm going to do while I'm here is I'm going to make the free look a child of the main camera just to clean up the view a little bit here. And so now, if I walk forward but rotate the camera, you'll see my player rotates and moves in the direction that I'm rotating the camera. But then if you're standing still, you could still get the full 360-degree view of the player. Now there's a few other things that I want to address with our player here, just to make movement work even better. So the first thing I want to add for our player is a jump feature. And so what we'll do is we'll go to the player input, and we're going to have to add a new action. So in actions, click the plus here, and we'll call it jump. And then under no bindings, we'll make a new binding. We'll make this the keyboard and mouse binding, and we'll make it the space bar. And then we'll add another binding for the gamepad, and we will make this the south button, so like X on the PlayStation remote. And then because we've changed this, you'll want to click Save Asset and then Close. And so then if we go back into our code, we can actually just add a new method called void on jump. And what we'll want to do is make a new variable here. We'll call it private float y velocity, and we'll just make sure it's 0 to start. And so on jump, what we'll do is we will do y velocity plus equals jump strength. And of course, with that being said, we need to make a new variable, public float jump strength, to control how high we jump, and we'll start with 5F there as well. And then in the method, we'll want to do controller.move, and we'll go 0, y velocity, 0. And you just want to make sure they're floats. And you want to do new vector 3. And so now what we're doing is adjusting just the y and not the x, because our jump is only going to be vertical. And so if I hit play and we jump, you'll find the first limitation of the character controller. Unlike a rigid body, it doesn't automatically have gravity. So we'll want to take care of that as well to make sure our jump works properly. So back in our code, we'll want a new variable again, public float, and I'm going to call this gravity scale. And I'm going to equal, I've got a reference pulled up here already. We're going to make it equal 9.81 because this is the equation for gravity. So back in our code, we'll make that 9.81F. And then we're going to want to do a few things to calculate the gravity as well. So here in the bottom of our update method, what we'll do is we'll do y velocity minus equals gravity scale times time dot delta time. And then we'll do controller dot move y velocity, 0, new vector 3, 0, y velocity, 0. And then we're actually going to multiply that by time.delta time again. And the reason we're doing that is because when you look at the gravity, you'll notice it's per second squared. And so that's why you multiply twice, just to make sure that the equation works properly. And so once more, if we hit play, and we jump, you'll actually see that we're running into a problem here, which we'll need to fix by messing with the player's jump strength. Alright, it's not the jump strength. Let me just take a look and see what we've got. Alright, so what it is that currently, if we just go ahead and make this y velocity public, and reload our game, you can see now our y velocity is listed here, and if you watch it when the game's running, it's constantly going down. And so no matter how high your jump strength is, it's not going to be enough to get us into the air with the y velocity. So to fix that, what we're going to need is a ground check. And so what we'll do is we'll make a new empty game object as a child of the player, and we'll call this feet. And basically what you want to do with the feet is position them on the ground. Alright, and so once you've got the feet, go back to your code, and we're going to need a new variable. This is a public transform feet, and then another one which is a private bool on ground. And so this one will be the location of our feet, and this one will be true or false whether or not we're on the ground. And now finally, we need to determine if we are on the ground. So I'll need one more variable here, which will be a public float, and let's call it ground radius. And I'm still not sure that's the best name for it. I might change the name here, but that's what I'm going to call it for now. And after our move, but before our gravity calculation, what we want to do is do if physics dot check sphere ground. No, we're going to do foot. Sorry, I named it feet dot position, and then we're going to do ground radius. So basically what this is doing is this is creating a tiny sphere at our feet position, and it's going to be the size of ground radius. And so if the ground is colliding with this sphere, then on ground equals true. And so now there's a few things I want to do. What we're going to do is we're going to make the y velocity back private because we don't need to access that and see it in the inspector. I'm going to make the bool for on ground, I'm going to make it public for now so that way we can see it. And back in our on jump, we want to set on ground. Actually, what we'll do is at the very end, so that way the player lifts off the ground first, and then we'll make on ground equal false. And so, when we go back into our game, after we save our script, and we go to the player, and we have to set the feet transform to that feet game object we made, and then hit play. The player is currently on the ground. So I'm going to play one more time to show you that. You can see it's actually not on the ground. So here's what we need to do. We need to select our ground, and in its layer we need to add a new layer, and we're going to call it ground. And then set the ground to that layer ground. We're going to go back to the code again. We're going to make a public layer mask ground. And where we did our check on the check sphere, after the ground radius, we're going to do ground. And that's going to make sure it's checking for collisions with anything marked as the ground layer. And we're going to do one other thing to make it a little easier to debug. So we're going to do void on draw gizmos, and we're going to do draw, or let me see here. Let's go back to the Unity documentation. I've got it pulled up here. It's going to be gizmos.drawSphere. So let's do that. Gizmos.drawSphere. And it's going to need a location. So that is going to be our feet.position. And it's going to need our radius, which is ground radius. This is going to draw the sphere, so that way we have a better idea of where the ground check is. So if we move our player, not our ground, up in the air a little bit, and we mess with the ground radius, you can now see the sphere. And so the ground radius was set to 0, which is why we weren't on the ground to begin with. I'm going to make it 0.2. And so you can see there's a little bit of play there. And if we press play on our game, our player should now fall, land on the ground, and on ground still is false, because what we need to do is we need to go in here and change nothing to ground. This was our sorting layer that we created. And now finally, if we hit play, we should get true. And we do. So we're almost ready to fix our jump. There's just a few more things that we need to do. So now if we're on the ground, and our y velocity is currently less than 0, what we want to do is just set a solid y velocity. So we'll make our y velocity equal 0. And so what that'll do is make sure that our y velocity isn't always going down. If we save one more time and hit play, when we land on the ground, our y velocity is set to 0, but you can see one problem of this, which is that our player isn't quite on the ground. So a fix for that is just to mess around a little bit with our y velocity. If we made it something, for instance, like negative 1.5, that will drag us closer to the ground. And you can mess with it a little more to make sure that you're completely on the ground. Now finally, if we jump, you'll be able to see that now we're able to jump, but there's still a problem, and that is that you can jump unlimited amounts of times. So one last time we have to go back into our code, And on jump, what we're going to do is say if on ground and we're going to wrap the whole method in this if statement. So now we have to be on the ground in order to jump. All right. And so there you go. That is going to be it for our player controller this time. Let me know what you think of the first tutorial. Please leave any likes, any comments, anything like that, so that way I know what you all think. And I thank you all for watching, and I'll see you again in the next video.